We're going to continue our discussion of operations with complex numbers. So I'm going to title this part 2, and we're going to start by talking about powers of I. All right, so we know what to do when we have an I squared, but we need to also be able to simplify I to the third or I to the fourth. And I'm going to kind of give you the goal right here. The goal is at the end of this, we're going to figure out what I to the 99th power is. Okay, so to get to what I to the 99th power is, we need to kind of start with what we do know, which is that I squared is equal to -1. Now, let's build off of that and figure out what I to the third is, I to the fourth, I to the fifth, and let's figure out I to the sixth, and then we'll kind of see if we notice any kind of patterns. All right, now when we figure out I to the third basically means that we have an I squared, which is 2 of them, and we need to multiply by another I to make 3. And so we know I squared is -1, and when we times that by another I, the result is going to be -I. So in a similar way, I to the fourth can be written as I squared times I squared, right? And I squared would be like taking a -1 times another -1, and so the result this time is a +1. So if you kind of get the idea of what I'm doing is I'm basically taking all these powers and figuring out how many I squareds go into them. So I to the fifth would be like I squared times I squared, which makes 4 I's, and I times that by an extra I to make 5. So this is -1 times -1 times an extra I is going to this time make a +I. So one thing I'm noticing is that the result is either going to be a ±1 or a ±I. And the other thing I notice is it goes negative, negative, positive, positive. Can you notice any more patterns with this? Maybe you notice that all the even patterns give a result of -1 or 1, where all of the odd powers give a result of -I or I. Okay, so let's keep going and figure out what I to the sixth is, which is going to be I squared times another I squared times another I squared. And that's going to be like taking -1 times -1 times -1, which actually takes us back to -1. And what you're going to find is that this pattern right here repeats. Okay? Those are the only 4 results, as you're either going to get a ±1 or a ±I. So I to the 7th would be, so if this is the same as I to the 6th, I to the 7th would be -1. And I to the 8th would be +1, and I to the 9th would be +I, and it's just going to loop and repeat over and over and over. So before we get all the way to I to the 99th, let's figure out what something like I to the 13th. So what is I to the 13th? All right, so before we do that, I do want to kind of talk about an exponent property right here, because we don't want to keep having to write out I squared, I squared, I squared, I squared, especially when we're trying to do I to the 99th. So what we can do is we can write this as I squared, and if we times it by itself 3 times, we can write that as I squared to the third power. Well, the exponent property says that when we raise a power to a power, you can multiply and get I to the 6th. So let's use that same logic here for I to the 13th. I to the 13th is I squared. Well, how many times does 2 go into 13? And it goes in 6 whole times. So what we're doing is we're basically saying that this is like I squared times I squared times I squared times itself 6 times, okay? And so that's only going to make I to the 12th. So we're going to need to multiply by an extra I to make I to the 13th. So this is like taking -1 to the 6th power times an I. Well, -1 times itself 6 times is going to be a positive. And the result is going to be a +I. So I to the 13th is really like the same thing as I to the 5th. So last question here, what we've been building to is what is I to the 99th power? Well, what we're going to start by doing is we're going to figure out how many times I squared goes into 99. Well, if you want to go grab your calculator really quick, and we take 99 and divide it by 2, it's 49.5. And so what that means is that 2 goes into 99 49 whole times. Well, I squared to the 49th power is only I to the 98. So we need to multiply by an extra by an extra I to make 99. So now what we're doing is we're taking I squared we're taking negative 1 to the 49th power times I. Well, negative 1 to the 49th power is going to make negative 1. Here's a nice little pattern that we're going to use when we do these, okay? When you take negative 1 and you raise it to an even power, you'll always get a positive. But when you take negative 1 and raise it to an odd power, you'll end up with a negative 1. So the result of I to the 99th is negative I. We'll come back to another example of that at the end to make sure that you understand that concept. The second concept that we are going to talk about is how to rationalize the denominator. It's this idea that to be simplified, the denominator of a fraction needs to be a real number, okay? So now we kind of have two rules for the denominators. We can't have a radical, but we also can't have an I in the denominator to be simplified. So let's just go over a couple key concepts here before we get into these examples. First key concept is that when we take an I and we multiply it by an I, the result is going to be negative 1. So that's one technique that we could do to get rid of the I, is we could multiply it by another I and turn that into a negative 1. The next concept is I want you to see what happens when we multiply conjugates. Let's suppose we do something like 2 plus I and 2 minus I. So remember, these are conjugates. They're plus or minus pairs. And conjugates, the conjugate of A plus BI would be A minus BI. Well, let's see what happens when we multiply conjugates. Well, 2 times 2 is going to make 4. 2 times negative I is negative 2I. When we multiply I times 2, we get 2I, and then this last one is I times negative I gives us negative I squared. Well, if we keep simplifying, the first thing I notice is that negative 2I and 2I cancel. But be careful with this last part, because what happens is it's 4 minus, and then we can replace the I squared with a negative 1. And so the result is going to be 4 plus 1, and it equals this whole number 5. So the conjugate is going to be a good strategy to use to go from having an I in the denominator and rewriting it with a whole number. So let's go ahead and look at a few examples, okay, of how we can rationalize. So example 1, suppose we have 3 divided by 2I. Now, there's nothing to divide here, so what we really are doing is rewriting this without the I in the denominator. So let's use that first key concept, that we know that if we multiply this by another I, that we can then change that into, we can replace that with a negative 1. But we're going to multiply by I over I because, again, this is really just like timesing by a fancy form of 1. So the numerator is going to be 3I, and the denominator is going to be 2I squared. So 3I and I squared changes to negative 1, and so the denominator is then negative 2. So a lot of times what you'd see is rather than the denominator being negative, we would just say that the fraction is negative, and we could either write it as negative 3I over 2, or you could write it as negative 3/2 I. Those two are the same. So what if we have a denominator like this? Okay, suppose we have 5I divided by 3 minus I. Well, this time, timesing just by a single I is not going to get rid of the imaginary part in the denominator. So we're going to use that concept of the conjugate, and we're going to double distribute that, okay? So again, multiplying by 3 plus I divided by 3 plus I is really like multiplying by 1. So let's go ahead and do some double distributing here and see what happens. 5I times 3 is going to make 15I, and 5I times I is going to make 5I squared. In the denominator, we're going to double distribute and get 3 times 3, 3 times positive I, and then we have 3 times negative I, and negative I times I is negative I squared. So when we simplify the numerator, this I squared is negative 1, so this quantity is going to be a negative 5. And since it is therefore the real part, we're going to change the order and put the negative 5 first, and then write the 15I. Well, in the denominator down here, we see that the outer and the inner cancel, and this becomes 9 minus, and we can replace the I squared with -1. So this is really 9 plus 1, and it's going to make a 10. So let's talk about how to simplify this a little bit more, because remember, complex numbers are written in the form a plus bi. We need to separate the real part and the imaginary part. So I'm going to separate by taking -5 divided by 10, and we're going to take 15i divided by 10 for the imaginary part. And we can then simplify each of these. Well, -5/10 makes -1/2, and 15/10, if we think about dividing by 5 and dividing by 5, this is going to be 3/2 I. And that's how we would write our final answer, is a real part of -1/2 and an imaginary part that's 3/2 I. Now, this last part here, we're going to just do a couple on your own. This is where you can certainly kind of make the pace of this what you need. So I'm going to put up 2 problems, and you can either hit pause and you can work on them on your own, or we can kind of stay together and work through these together. So I to the 1028 power, and then we're going to do 4 plus 2i divided by 5 minus 3i. Okay, so hit pause if you want and kind of think about how to work through these. And or you can stay with me and we'll go over them together. All right, so when I do this, I need to think about how many times I squared goes into 1028. So I need my calculator here. This is 1028, and I'm going to divide that by 2, and it actually goes in 514 times. And so I can rewrite this as I squared to the 514 power. And since it goes in evenly, there's no i's that are going to be left over. So this is like having -1 to the 514 power. And we've talked about this. When you take -1 to an even power, it's always going to equal a +1. I don't actually have to put that into my calculator. There's a nice little pattern that helps us with this little shortcut, where if we took it to an odd power, it's going to make a -1. All right, so for this problem, what we're going to do is we're going to multiply by the conjugate 5 plus 3i over 5 plus 3i. All right, start double distributing, see what happens. So the numerator is going to be 20 plus 12i plus 10i. 2i times 3i makes 6i squared. The denominator is going to be 5 times 5 plus 15i minus 15i, and be careful with this last part. It's always going to make a negative because there's always going to be one positive and one negative. This is going to be -9i squared. And so a couple things we can do to simplify this. 6i squared is -6. And what happens here when we take -9 times -1, this whole part is going to make a +9. And so let's simplify. And we can combine the 20 with the -6, and we can rewrite this as 14. And then what we're going to see is the 12i and the 10i are going to combine to make 22i. All right, the denominator is going to be 29. It's going to be 25 plus 9, which is going to be 34. And then we've got this 15i minus 15i is going to cancel. So you know what, I'm going to write this a little bit more in the middle. Okay, so finally here to simplify is we need to split in a way. Split the real part, which is 14/34, and the imaginary part is 22 over 34, and we can simplify each part. Well, 14 divided by 34 is going to simplify to make 7 over 17. And 22 divided by 34 is going to simplify to make 11 over 17i. So hopefully that makes sense, and we'll get a little bit more practice with this. And thank you for watching.